What sets the MACH reactor apart and makes it unique and revolutionary compared to other technologies in the industry?
I think to answer that question, let's have a look at what these other technologies are, not by name, but how they operate. So the different categories that are already out there that have been used. You get the lance type technology, which is the cheapest, and by far I would say there's more of them on the market because they've been around for so long and they're easy to use, but they're the least efficient of the lot because they create really large bubbles. They don't have a lot of mixing in them. And then you get the, let's call it the static mixer type units that, on the one hand, you get units that have orifice plate design, where they have sections of pipe with orifice plates in them to create a bit of a baffle, a bit of mixing as you're pumping through it. So that has a slightly higher degree of efficiency than a lance because there is more mixing and you can shear those bubbles down into smaller sizes. And then on the other side of shear reactor, you get the reactors that have the meander system, where you're pumping in through you can imagine it as a pipe with steel balls in there. So the pulp has to move around those steel balls to get to the other side, and we create a bit of mixing, eddy formation, etc. In that manner. And these, as you can see, you're trying to force something to happen. You're trying to break a bubble down. You're trying to force this mixing effect by forcing the flow to either go through these small orifices or to push past these steel balls, etc. You notice the words I'm using. It's like we're fighting nature. We're breaking, pushing, etc. How is the MACH different? Now the MACH is working in complete harmony with nature, as opposed to all of the other historical methods. And how we do that is through a process of cavitation. So we're pumping slurry through a system of venturis. And as we accelerate the pulp through the venturi, we create this suction effect between the venturi. So we actually suck in the gas, we pull in the gas. And then between the two venturis, as the one venturi is jetting into the other venturi, we create these areas of extreme turbulence and mixing that helps us disperse the pulp. And there's two things that already come out of it. Number one, these historical devices use mixing and a bit of shear at best. Here we go next level. So we move beyond the shear phase and we're actually into cavitation zone. So we have very extremely high velocities through these venturis where we generate these vacuum picobubbles, which is the finest of the bubbles that are generated through all these other units. And the finer the bubble, the better the efficiency. So we're getting that with the MACH. And it's really also has very low wear. So all of these other historical devices have to be replaced every couple of months. Or if not the whole reactor, then some wear part has to be taken out and you've got to replace it with a new part. Whereas the MACH reactor is manufactured basically once in its whole lifetime. So you manufacture it, install it, and it will be there 10 years down the line, still operating without you having to fiddle with it or fix anything or even clean anything. And that's, at the end of the day, it's those aspects. The fact that it is self-aspirating, so you don't need pressurized gas. You can draw the gas in. It employs a principle of cavitation as opposed to mixing and shear. And then it just will outlast the life of your project. And it's the only reactor on the market that will do that.